Okay, this is question 5 on the multiple choice, and I just kind of wanted to show y'all something. I don't know if you can really see this, but the advantage of, actually I'll show you here, the advantage of highlighting these is really there. First of all, I found the equation. It's Newton's second law solved for acceleration, something to do with mass and weight in the gravitational field, and narrative, mathematical, and graphical representations, re-express a free body diagram, and then connect concepts. Yeah, and then it says mathematical routines. Remember, math does not necessarily involve numbers, and usually when it does on the AP test, they're pretty easy. So anyway, let's find the important information. This is a really weird one because to me, my first instinct, I thought it was a top view, but it turns out it's not. The figure above shows forces exerted on a block that is sliding on a horizontal surface. So that means it's going this way. And again, this looks like a top view, but wait. Okay. Sliding on a horizontal surface, the gravitational force is 40 newtons. And hopefully you know this is, if it's a box sliding around, it's near the surface of the Earth. So that's going to be its weight, 40 newtons pointing down. And the 40 Newton normal force. So right there, that tells you there it's on a surface. And this is just a really messed up looking free body diagram. I'm guessing that's where the re-express free body diagram thing or something. So this is a rough surface that it's on. So that makes a little bit more sense, I guess. It's a box sliding, and I'm guessing, I just kind of drew this because it was in the X direction. I am guessing it's going that way, going to your right, positive, negative. I'm guessing it's going that way, and that the frictional force is slowing it down. So it's kind of like it was going on a smooth surface, then it hit a rough patch, and that started to slow it down. So, and actually, that's the only way it could act, because friction has to go against the motion. And if it were going the other, if it were going negative, then the friction would be going the opposite way. So you can eliminate the ones that say to the right now. So it cannot be those two. All right, so now let's get the number. Is it 1 or 2? Now this is where it gets like kind of weird. So there's a coefficient of friction. So we know normal force, we know weight. I'm just putting check marks by these. And then you know coefficient of friction, which would be kinetic friction because it's moving and it's not varying like static would, is 0.2. And coefficients don't have numbers. So you basically need to use this equation. I don't know if you can see it. It's Newton's second law. Okay, so acceleration equals net force over mass. Oh yeah, since the since the velocity is going this way and your only force that's not balanced on it, because normal force and weight are balanced, is going to be your frictional force. So that means your acceleration has to be in the same direction as the frictional force. That's why I scratched out those other two just a second ago. So this is going to be the acceleration. So remember, to find your net force, like it's mass times acceleration, but also it's big force minus little force. So it's what's going parallel to your acceleration and what's going anti-parallel, or just in the opposite direction. So we only have one of those, it's force of friction. So I'm going to come over here, acceleration equals net force over mass. That's going to be acceleration equals force of friction over mass. You might be like, oh my gosh, I don't have enough information for this. Yes, you do. So frictional force is this equation. You can use your equation sheet or hopefully remember it. Okay, so Miss Coley says this spells fun, like F mu N. I think of F mu, normal force, like they don't like each other. But whatever. Basically, friction is how rough the surface is, which is mu, and then like how hard the surface is pressing against the object, which is normal force. So you know that the coefficient of friction is 0.2, and then you can multiply that by your normal force, which is 40 newtons. I mean, if you need a calculator, you need a calculator, but I think of it as a 20% tip on 20% tip on a $40 bill. So 10% of 40 is 4. Double that, that is 8 newtons. And you know what? I'm going to not write all this. That is just 0.2 times 40. Okay, so for your mass, well, if you look over here, your mass equals 40 newtons. So if I divide both sides by little g, you would get 40 divided by, remember acceleration due to gravity is 10, Okay, so what I did here is I just divided 40 and I broke down Newton to kilogram meters per second squared, and then I divided it by 10 meters per second squared. And remember, I'd flip it because I'm dividing, so they cancel out. You do not have to do this. I actually probably don't if you just like see what the number should be on multiple choice. I'm just showing you. So kilograms, that's the right units. 40 divided by 10 is 4, so your mass is 4 kilograms. Okay, so I just plugged in my 8 newtons for my frictional force, and I did it as kilogram meters per second squared, and divided by my mass, which is 4 kilograms. So that gives you 8 over 4. So that would be 4 goes into 8, 2 times. D is the answer.